tasks. Yep, cool. Right. Right, morning everyone. I'm conscious today it's just before lunchtime, so I'm going to try and rattle through this. We've got quite a lot of slides, a bit of detail in some of the diagrams. So if you guys are struggling on seeing diagrams and that, then please come forward and that side of things. Okay, so I'm Iain Worsfold. I'm a global hosting architect for Rentokil Initial, and I've been working with Rentokil for 10 years. Part of my day job is really looking after the VMware infrastructure for Rentokil globally, side of things. And I'm here with James.
I'm James Tiffany. I'm a technical adoption manager at VMware, and I've been working with Rentokil since I joined the company.
Okay, so a bit of an agenda today. Just go quickly talk about who Rentokil are, what challenges we faced about on-premise hosting side of things, what is GCVE, which James is going to just step in and talk about, and then I'm going to sort of go through, between myself and James, in fact, go through kind of the steps that we took around migrating workloads to GCVE, and then just a little brief on impact on operations and conclusions. So I just wanted to ask if, is anyone using GCVE here? Apart from the Rentokil people that are going to be heckling me, sort of things. Is anyone using any other kind of like AVS, VMC on AWS, or looking to migrate at all, or no? Okay. So this may be some interest, but okay. So a little bit about Rentokil Initial. So we are regarded as the world's leading pest control company. We also have a hygiene and wellbeing services company. So hygiene is pretty much our initial brand. More of the wellbeing is around the Ambius plants and that side of things. We operate 93 countries around the world, although Brad, in his presentation, he may tell you differently because, you know, he's constantly changing.
Said that, because he tells lies. I tell lies. I took a guess and said 93, and it sounds like it was good.
I think we're on the money there. Okay. We are highly acquisitive, so we do purchase companies pretty much every week across the globe. So, you know, those 93 countries, they're pretty much every continent except Antarctica. Kind of thing. Mission, vision and values, you know, I'm going to really point out around the values side of things, because that, for this migration project that I've been doing for the past couple of years now, and still got another year or so to go, you know, really actually is something that was really at the heart of what we did. So a bit about project background and, you know, what we, you know, kind of give a background of what our challenges were, sort of things. So globally we operate effectively 3 data center regions. I've focused on EMEA because we did that a couple of years back. We've actually literally cut over the APAC region as well, so we've still got North America to go. One of the big challenges, you know, the reasons for moving to GCVE from an on-premise infrastructure was that, you know, as kind of Joe mentioned in his keynote this morning around, you know, there's a lot of organisations refactoring applications and that sort of thing. So we've been going through that sort of journey, as it were, and, you know, we've been doing it for several years, and we've still got those new, you know, we've got some nice new front ends and all that. We've built natively in Google Cloud, but they're still talking back to on-premise side of things, talking back to our traditional infrastructure, just traditional VMs. So, you know, with that, there's a lot of kind of data synchronization that's happening and that side of things. So, you know, what we wanted to do with this project was to actually bring our VMs, our back-end infrastructure closer to where those applications are being refactored. And there's a couple of other challenges we've been facing around time-consuming hardware refresh cycles. You know, Joe mentioned about hardware supply chains. I think we've seen how fragile the supply chain is in recent years. And obviously, you know, as Joe mentioned in his, you know, about sustainability objectives that have come down. So, what is GCVE?
So for those of you who don't know, so a lot of people would have heard of Amazon, Google, everything like that, but what GCVE is the ability to run the vSphere software on a hyperscaler's platform. So they own, manage, supply the hardware. There's a VMware layer on top of it, and then you can consume the actual infrastructure on top of that. So GCVE allows you to make use of a VCF environment, so that gives you vSphere, vSAN and NSX out of the box. They do the base configuration, hand it over to you, and then you can start consuming. And the great thing about that is it gives you, because it's taken away all the infrastructure part of it, you don't have to worry about the networks, you don't have to worry about hard disk failing, someone else will come in and do that, so it takes that stress and worry, and then you can just start using the actual products themselves. So GCVE is not everywhere that GCP is, but you can see from the map it's in a large number of areas. And all of this will be covered by Iain in, it helps you decide where you're going to be located. You can choose a data center that's close to yourself and your applications or your customers. But things like the 2 zones, that allows you to do stretch clustering, give you much higher availability, so that builds into the decision-making process as well. And the networking, so Google have invested massively in the submarine links between continents and everything like that. So you get a massively highly available, fast networking that you can use. So if, like Rentokil, where you're in multiple of geographic locations, you've got that high bandwidth internal networking to be able to talk amongst those. Plus you get the ability, like Iain mentioned, is if you are transforming your applications, you've got your GCVE instance, but you've then got your Google instance, and you've got fast, high connectivity between the two as well. Use cases, so these are the general use cases that most people look to go to the cloud with, but if we look at Rentokil's specific reasons for doing it is the cloud migration. You get disaster recovery because you can do multiple zones, multiple regions, things like that. And application modernization, you've got the close proximity to the Google services. It helps you then build out your next gen products with fast availability.
Okay, so I was approached around this whole deal. We'd had several meetings with Google and those and around migrating ourselves to the cloud, as it were, or to Google type of things. But really, how do we actually get started and kind of the journey, because it's not as easy as how some of the sales guy would say is just, well, it's just vMotion, isn't it? You just vMotion the VMs up and it's all fine. So one of the first things to do, and this is really focused on data center closure side of things, but I do recognise that there might be other use cases, as James mentioned about extending data centers. So somewhat different approaches. But the first thing really is around what is it we've got in the data center side of things, and there's several. As I've listed here, there's several ways of grabbing those different inventories. I mean, obviously RV Tools is pretty obvious for most people that are VI admins side of things, but there's all these different types of documentation that we can search through and that. And the last point around stakeholder management, one of the things that we really focused on was around, get a list of VMs, get a list of all the various upstream and downstream components that build up a service side of things, and obviously map, who's in charge of that service, who are the stakeholders of that. So when I'm talking about stakeholders, it's really things like, well, who's the product owner, who's actually in charge of making sure that the payroll, for example, runs, side of things. Who are actually the consumers of that service. So it's normally the HR team. Let's take that as an example. There might be specialist administrators that administrate and update the application or the service on a day-to-day. They need to be kind of consulted and informed And there may be external parties that we need to obviously get as well involved around, obviously we're making this huge change of where it's located. How is that going to be impacted? Obviously, one of the key things, and I am, conscious I am of time, so I am going to be skipping some points as we go through this. But one of the things that really comes out from, talking with the stakeholders is thinking about a product roadmap side of things, because obviously when you look at a migration, typically for us it's between 6 and 9 months from start to finish, and in that time, one of the things that we need to understand is, well, they may have their own projects, they may be doing, refactoring their stuff or moving it to SaaS, or having their own ideas. So, getting a good idea of where that lies, I think is really important. Things like operation, what times, obviously, let's take the payroll example. You don't really want to be migrating the payroll application, just before you're doing a payroll run side of things. It's not probably a good idea. So, yeah, that was really key for us to gather that information.
So as Iain mentioned, as part of the mapping of services and things like that, the way you can do it is obviously go to a service owner, say what do you own. They'll tell you they own 5 machines maybe, and then you discover they own 10. So there's a product called ARIA Operations for Networks, used to be called Network Insight. And what that does is flip it on the head. And what it does, it gives you the ability to do application discovery. So it looks at machines, it looks at what it's talking to. So instead of asking someone what they're doing, you can actually go to that person and say, your application is actually built up of this, not this that you thought about it. And as part of that, you can look at the tagging, and you can start building up those relationships between it. But it's not only the application, you can then see what else it talks to. So all of this can then be used when it comes to the actual migration, because you know what talks to what, and then you can start doing things like wave planning, which we'll cover in a second. But the other great thing about it is it's not only saying this machine's talking to that machine, it's saying this machine's talking to that machine on all of these ports. And what that allows you to do is, a lot of people might not have NSX, but when you go into the cloud, you get NSX by default. So that then allows you to potentially start building up DFW rules using microsegmentation, because you've got a list of what talks to what over what ports. And the great thing is, it then it's got connectivity into HCX, which will be the product that you'll potentially be using to do the migration. And that's when it goes into the wave planning, and it's using the information that is gathered to say this application is built up of, say the normal web application DB. Well, you want to move those all together. You don't want one in the cloud, one on-prem, and the other bit in the cloud, because you'll get the hairpinning, tromboning, and everything like that, puts latency in there. So what it allows you to do is build up a plan of, say, I want to move these 50 machines this week, these 50 machines this week, and the plan is that you get all the dependencies that it's talking to.
So we've done kind of that discovery piece, that analysis piece. Now we're kind of looking at okay, how do we get the migration? So, James has mentioned around, grouping those applications. Obviously we've got groups of applications, but those applications may have dependencies on others, services and that side of things. So, when we're looking at the actual migration, what we're trying to do is try and group in services into a particular wave. So, that's basically a period of time where we're actually going to move, this group of VMs services over in this one, and grouping them. One of the things we've got to be conscious of is things like the low latency, the high throughput side of things, because if you can think about it for a second, on a day-to-day basis before you're migrating, 2 applications typically have maybe less than a millisecond of latency, and all of a sudden, you're migrating it from one to the other, and if you haven't got it in that group, you can be multiples, 10, 20 milliseconds of difference, and that can really make an impact. And I'll kind of touch again on that point in a bit. Really great to, really, important to have around post-migration testing as well. Make sure that when you're doing the migration that, you've got someone to actually test, not only to make sure it's functioning, but also make sure it's performing right, because you don't want to go into the following day, working day side of things, and the business are complaining and sort of saying, this is poor performance and, we can't run. There is a piece around rollback and fix forward, which I'm going to talk a little bit more into the next thing around migration options side of things. So what we've used for migration, one of the things that GCVE comes with is HCX. So that's kind of our default standard for moving VMs across. And there are 4 different migration types. Now, cold migration and vMotion kind of self-explanatory because we're pretty much probably used to that on premise. But two of the more unique options is around bulk migration and replicate-assisted vMotion. And it's easy enough to sort of say, well, with replicate-assisted vMotion, that's basically we're migrating the storage and in one go, and then we're vMotion in VMs, so surely that's the best option side of things. But there's a few things to actually think, to consider here. One is that with bulk migration, you're retaining a copy of the VMs on the source side. So if you do need to quickly roll back, you could, it's a simple case of shutting down the VMs in the GCVE environment and reconnecting the network adapters and powering up the VMs back on the source side. So that's something to really consider about. Also remember that with replicate-assisted vMotion, even though the storage is concurrently migrated over to start with, and then you get basically a point where you can actually cut over side of things, that actual cut over is done on a per VM basis. And it can take sometimes, depends on the size of the amount of memory side of things, but picture this, if you've got a 3-tier application, that database server is going to be over for maybe 15 minutes before the application server's coming over. So if you're doing a migration when something's running overnight, maybe, and getting ready to be available for the following day, if there's something that delays that and causes latency with that side of things, that can cause other problems as well. There is actually 2 other migration options which are kind of outside of HCX. One of them is actually rebuild and replace. So this is coming back to talking to the stakeholders and talking about, okay, well, I've got my application, I'm planning on doing an upgrade side of things. So, okay, well, rather than us actually moving the old, server 2012 box over side of things, why don't we just build up a new, server 2019 box, for example, and then, we'll migrate the actual application over differently. So we've done this with backup and DR systems ourselves. Obviously, if you're involving stakeholders around that, just be cautious around that project dependency, because they have their own agenda and you've got yours with the migration. And then there's obviously retirement, which is typically going to be your vCenter and NSX managers, because obviously with GCVE you get that vCenter and NSX managers. You're not going to be migrating those over, and there may be other on-premise systems that need to actually be retired as well because they're no longer required. So, workload migration. Again, I kind of talked about being sure about the hours of services side of things. I'll get to the point around migration and concurrent migrations across multiple service meshes when in a few slides time. But in terms of the next point further down around the size of the migration, it's easy enough. I think HCX does like 200 VMs in a migration wave at a time for each interconnect appliance. If just because there's that available to you does not mean that you should aim for that. What you've got to think about, and this has worked out really well for us, is kind of limit the number of services impacted, because when those VMs are migrated over, if there are issues and you need to roll back, you haven't got 20 people coming at you, sort of thing. You've only got a small group of people. So, we found that it's much better to do very small but many migration waves rather than one big migration wave at one time. So before going, so the next bit is around network extensions. So this was actually, I've got a couple of diagrams like this. So one of the things to actually go through is, first of all, we spent quite a bit of time doing microsegmentation in our hosting environment for many years. So this was using NSX DFW, and this worked out really well, side of things. But when it comes to actually migrating over, we've got NSX on premise, and then we've got NSX in GCVE, but there's no federation between them. So as your VMs migrate over, if you don't actually by default, as they migrate over, you'll lose, even though you've got this network extension coming across, they'll actually lose connectivity because the rules will suddenly break. So the way we found around that was, we instead of actually using service tags, we added IP sets to our security policies side of things, and obviously we had a replica of each of the DFW policies on either side. So as VMs migrated over, we didn't get that interruption around that security. Another thing to point out was with HCX, there's this feature called mobility optimization networking. So one of the things that as you do this network extension across is that your gateways are still on that core switch, still on premise. So when you've got an application, and we've got many applications like this, where we've got a 3-tier application and they're all on different networks and that, you can imagine, typically without MON, that's got to go back to the core switch and come back forward. So that's going to have huge latencies on us. By setting MON on our T1 internal, effectively what we're doing is we're putting in /32 routes basically on that T1. So basically when the web wants to talk to the app, it's actually going back up to the T1 and back down. It's not going all the way back and back to the core switch back on premise. But this only works really where you've got the same T1. If you've got it in different T1s here, side of things, like we've got here for our DMZ networks, for example, that's where we've hit some problems. So in that sense, what we've needed to do is we've done one or two options. One option is we'll create a T1 just for the migration, just for that transition period, and we'll connect all our networks up over here, and we'll solely rely on the DFW to maintain security between those networks. Or the other option really is to move those applications right before we do the network cutover, and that minimises the transition period and therefore the latency period when that experience. So into the build phase, there's a few considerations which I'm going to run through, sort of things. Taking us back to the global map, one of the things that we needed to work out at Rentokil was, where our customers' base is. Are there any legal requirements or jurisdiction requirements that mean that we need to put our hosting services in particular regions and services? It's also worth actually, and this comes to, that's my laptop. It's also worth actually coming into into the, there is actually a GCVE sizing tool that's available. You get this through your Google account team side of things. So what you do is you basically input all your numbers of VMs, your CPUs, RAM, etc. side of things, and what it does is it spits out the number of nodes that are required for a particular cluster. Now there are some limits when it comes to actually building up a private cloud. Obviously, it's a vSphere environment with vSAN, so certain rules apply. So you need a minimum of 3 nodes. You can do a single node private cloud to get you up and running for 60 days. what we found when we did this for our disaster recovery private cloud was we started with a single node and then we upgraded it just to save on cost side of things. One caveat with that is when you do a single node, you'll get a small NSX edge node on there. And when you upgrade, that just doesn't get upgraded. So as you upgrade, you'll eventually, what we found was we had packet drops, etc.
And we needed to raise
a support ticket with Google to increase that.
Additional storage.
Additional storage.
As I mentioned,
as well as doing production migration, we also have a disaster recovery private cloud.
And in this use case,
we've got obviously very small amounts of compute on a day-to-day basis, but obviously a lot of storage consumption that we need to provide for all those recovery points.
So we were pretty fortunate. With Google to actually be invited to use
a beta program of their storage-only nodes. We've been running that for the past year. Side of things.
What that basically means is that
it's an additional node that we've added to our cluster side of things. So you get all the performance benefits of vSAN and that sort of things. But obviously you cannot run VMs on there, and there is a bit of a discount against a regular node for having that in place. The other rule with that is you can only have up to 50% of the total nodes in your cluster to be storage only. So you can't sort of start with one node as a regular compute node and then have the rest as storage only. There is some limits around that.
And then I just wanted to touch on there
are other data store options. We've not implemented any of these, but if you were looking at other storage options, maybe they might be more cost effective or other use cases. Then there's Google Fast Store and NetApp Cloud Volumes. They present like an NFS data store to your cluster, or there's in-guest NFS shares as well, which basically what they're doing there is that you're able to actually attach an NFS mount point into your guest VMs, and you can obviously use that for particular use cases there.
The other bit around,
in terms of when building this is talking around the CIDR range. So this is, for those, I don't know if any of you are into network administrators and that sort of things, but the size of your CIDR range that you pick right at the beginning when you deploy your private cloud will dictate how many nodes you can actually deploy. So, if you pick a 24, then you're limited to 10 nodes side of things, and that's it. If you want to go beyond that, it's kind of a redeploy your private cloud and do a HCX migration or something.
The other thing to point out is around
HCX network extensions. So, with each extension appliances, I think it's eight networks that you can extend across. So if you need more than that, or if you're thinking about bandwidth constraints, I think that's about 6 gig. I think is the maximum in terms of each network extension appliance. That's something else. Particularly on this top end, that's going to dictate what side of range you need.
And in addition to that, there's
other ranges as well, other banks of IPs, and these got to be, when we're talking here, these are quite big ranges that you've got to kind of assign and reserve, which have got to be, completely spare in your global infrastructure. So, talking about HCX service meshes.
So one of the things that we actually found
doing this, doing subsequent migrations. When we first started this, we actually just created one single service mesh. We just did all the migrations across that way. Later we actually, what we found was that we were hitting some limits in terms of there was only so many VMs that we can migrate at any given time. So by actually using multiple service meshes, we can actually use multiple HCX interconnects, and this means that we can actually, providing that we plan our ways accordingly, we can actually do simultaneous migrations
or VMs, over different service meshes. So if we've got something in the C cluster here or workload cluster A, they will do different, concurrent migrations. So that was kind of something that was really new. Another thing, just to point out is around the management. Network up here. So when actually preparing to actually do this migration, things like the vCenter, we had to re-IP because that was on an extended network, and obviously at some point you're going to need to cut over that network. So at that point, you've got to make sure that you're not actually losing connectivity to the vCenter side of things. So that's something else that we had to pre-plan and move across. Conscious of time, so I'm going to rattle on through. So once we've done all the, in this scenario, what we've done here, just to bring up to speed, is basically we've migrated all the workloads over into GCVE side of things, and we're ready to do the network cut over. So there's a couple of things to actually point out. So first of all, again, I've spoken about the management network and keeping that separate, but there are other network services. So I've put here client VPN, but if you've got other network services that you could actually migrate separately, that was one that we could do. We could actually build that separately before we did the network migration. So that's kind of a rebuild and replace kind of migration strategy with that one. But actually, when you're actually cutting it over, all your networks now on premise have all been disconnected. So before you actually do that, you need to make sure that is completely clear. There's no, and this is again part of that discovery piece where you're understanding. Okay, we're going to cut these 3100, 3200, for example, networks. Are there any physical appliances, or are there any other services that we're not actually migrating? Maybe if we're doing depending on what our migration strategy is, then we might need to write re-IP or that, because once you've cut it over, your routing and all that, all your gateways are now living on these T1s. Sort of things. So other things as well that we needed to actually think about as part of this is obviously, we've got a number of branches across the globe connected to our SD-WAN. So there was a big, obviously a big routing change. Things around DNS, obviously, unless you're bringing your own /24 IP range, not many organisations have their own block of public IPs. Your public IP addressing for your workloads, let's say our brochure website's down here, that's all going to change. So you're going to need to actually update all your DNS configurations. There's a couple of ways that we've tackled this. One is to reduce the TTL on those public DNSs down to very low. I think it's like 5 seconds. I think we got it down to. Another way of doing it. Another way of doing it is if you've got, say, a CDN in front of it. So if you've got something like, for example, Cloudflare, for example, that sits in front of your websites and that, then that's another way you can actually, because you're just updating the Cloudflare configuration at that point. So that might be something that you might want to do beforehand if you've got a chance. It's quite a big task actually to do a migration to, say, something like Cloudflare or a CDN beforehand. So impact on IT operations. So on Google side, for us, data center power and cooling, that was actually with our colo, so that didn't really, change. It was just, instead of colo provider A, it's now Google. But things like physical servers, networking, the vSphere and vSAN, so pretty much everything I kind of look after side of things, that's all with Google now. And also the support escalation. So instead of going directly to VMware, where we were before, we're now sort of contacting Google, and then the support gets kind of escalated up to VMware when it needs to. But we are still responsible for our data. We're still responsible for the patching and management of our VMs. Providing backup and disaster recovery, that's still on us. and obviously user things like user accounts, so who's got access to our environment as well. So kind of go through the conclusions. This is kind of a bit of a summary sort of thing. So discovery and analysis. Again, it's very important around the stakeholder management side of things. Understand who they are. Understand what their migration, what their plans are, what their roadmaps look like. Think about the migration options. It doesn't always have to be replicated system vMotion. There might be other migration options out there that would better fit. When it comes to building, use this. If you can get hold of the sizing tool and use that. Obviously, also when you're building your cluster, it's really important to engage with Google themselves. Let them know how many nodes that you need, because they actually need to work with the capacity team to make sure that there is actually enough nodes available. Side of things. Again, think about those side ranges. And then when it comes to the migration, try and obviously, I appreciate this may look contradictory, but concurrent migrations is really important, where you can use that multiple service meshes, but obviously limit the number of services that you're migrating at the same time, so you're not overloading yourself the following day following that migration with support tickets if issues do arise. And there's a couple of things actually I didn't actually mention around post-patch deployment reboots. So that's another thing that we actually had experience of, particularly with bulk migration. So just as a reminder, bulk migration is the method of, we've got a VMs on premise, we're going to migrate, we're going to first replicate all the storage over, and then we're going to basically power down the VMs on prem and bring them up in GCVE. Now, if there's any post-patching deployment reboots, if there's a VM that's had patches deployed, it's typically Windows VMs, and it's waiting for a reboot side of things, that reboot's going to happen, and that can really, that's got us sometimes. So it's really important to kind of, I think in recent cases we've actually put a little pause on actually putting updates on our VMs just during that migration window, just to avoid that issue. Also note existing issues. So that's another thing as well, is that when we do the migration, we're migrating VMs over, and then we're asking those the service owners and application teams to do testing. And then they come up with issues. And say, well, this isn't working. And then they blame the migration. When in actual fact, it was actually an existing issue that was already there. Maybe, for example, the disk was already, was filling up, side of things, and maybe the reboot actually of the VM, caused something that was already there already. So it's definitely worth noting any existing issues if you've got a service management tool base, and and it's and you can see issues related to the instance. Again, it's that engagement with that stakeholder, with those those service owners, and that talk to them and actually make sure look, is it I noticed these issues. Is it okay to actually still migrate, or do we need to hold back until those issues are resolved? And then things like the network cutover. One of the key things I think I didn't mention actually was about whitelisting public IPs. So again, as you migrate over, those public IP addresses are no doubt going to be changing. And what we found with, particularly tax authorities, I think it was, they actually whitelist what IP addresses we send those tax returns back to, side of things. So we need to actually work with them to start with, and you can actually pre-allocate the Google IPs up front beforehand, so you can actually let them know what the new public IP address is and when it's going to change, so they can kind of prepare for that. And then just a quick summary again about what we're still responsible for. So obviously the security, backup, and DR. And the last kind of bits around it is, and again, it's for us. Really, what's really made it successful was, that early communication with stakeholders, but not just that right at the beginning of the project, but that ongoing communication throughout was really important for us. Definitely the relationship with both VMware and Google is really vital, because, and that again is not just during the migration that's going forward as well, because this is, particularly with Google, this is kind of going into GCVE. This is kind of an hour partnership, because there's that shared responsibility model side of things. So you kind of need to work together,
and then strong teamwork.
So
that is probably
the most important part for a successful migration.
I was involved
with a network cutover literally the day after I came back from VM Explore a couple of weeks ago. Side of things. And on that call, we had people from the North America team. We had people in EMEA. We had a person in South Africa. We had people in Asia, and we had people in Australia, all kind of coming together to make this work and make this happen. And that was just the networking team, because there were so many changes that we needed to make. But again, it goes back to that real stakeholder management, keeping them up to date, and
that felt rather quick than I anticipated.
So
I've put a link.
I've put a link to my LinkedIn is here. I'm happy to just reach out if there's any sort of questions afterwards. But I'm happy to take questions now. If not,
lunchtime.
I'm downstairs for lunch.
Yes.
You've been using it for a year.
Yeah.
It was a beta program, but did you have your production workloads on it?
That was just for disaster.
That was just for disaster. That was just for disaster recovery side of things. I think one thing actually is I wasn't really comfortable with doing it for production. Really because it being a beta, we kind of had to actually make and run and configure DRS rules ourselves. So with DR, it's relatively straightforward, because it's pretty static in terms of the workloads that get deployed there. Once they're deployed, it doesn't really change that much. But with production, you're always building stuff, and there's always that danger. It was done on a kind of honesty box basis sort of thing, where we'd actually it was kind of a gentleman's agreement that we won't run VMs on there side of things. Now, I do think it is available, but it's only just been made side of things, and it is a particular node. It is a different node type that you kind of deploy in there side of things. So yeah.
How does the cost stack? Your test teams and your test teams
Yeah.
Some math around some math. Is there any significant difference? Cloud rather than Google Cloud rather than
we did extensive cost analysis and that between it, and
I try to avoid it as much as possible. But I guess what I can say is, it is extremely close from what we've seen in terms of balancing the on-premise to the Google Cloud. But you have to consider those other use cases as well. Thinking about, obviously, we're trying to refactor some of our applications, so we've got that proximity with those applications. Hardware supply chains. I mean, Joe talked about getting access to graphics adapters, etc., and that sort of thing. So if you've got access to, say, Google services, that may prove beneficial to us. Side of things where we're not holding up projects, for waiting for GPUs.
Some of that can also depend on where you are. I've got a customer that is going through a massive hardware refresh, so at that stage they had the choice of either spending a lot of money to replace what they had, or look at a cloud option as well. So if you're quite far down that journey, then can make it easier to justify the costs, because you're going to have to spend money either way.
And it is, I mean, it is
Yeah,
a challenge.
and it is. I mean, it is a challenge as well, because it's going from kind of a capex model to an opex model sort of thing. So it does, people say, it's cheaper to run it on-prem and versus cloud, but it really does depend on your depreciation model sort of things. If you've got a more aggressive depreciation model of 3 years, for example, and that, then it kind of swings the other way sort of things. But if your depreciation model is 7 years, then actually, it swings back to on-premise, and that's what we've, yeah.
Cool. Well, thank you, everyone.
Yeah, thanks everyone.
Lunchtime.
Yeah, thanks everyone.